What's up, everyone? Charlie here. We're going to go over the Webull tutorial again, and we're going to continue on with this. So far, what we've done, just for a brief recap, we've created a Webull class. We've created a getTickerID function that's going to convert the ticker ID to the symbol we need, or vice versa. It's going to actually convert the symbol that we input to the ticker ID needed to call the API. And then we've created a analyst ratings function to get analyst ratings data. We've created an analyst ratings model to store the attributes. Then we've created a short interest function and a short interest model to hold the short interest attributes. So we're going to continue on with this, and we're going to go ahead and do capital flow. Now this is going to be inflow, outflow based on player size in the market. Could be a beneficial uh, function to use for those of you that are into data analysis for markets. So we're going to define capital flow. We're going to pass in self and symbol as a string. And we're going to do the same thing, ticker ID equals self.getTickerID, pass in the symbol. And just like before, the endpoint equals, and then we're going to paste in the endpoint, which to get this, again, we head over to Webull.com, and let's see here. The endpoint you're going to be looking for, if you go to the stocks tab and click around on the page, remember you don't have to be logged in for this. Look for ticker question mark. So you can filter, type in ticker question mark, and it's going to be this top one right here. And you'll see the word capital flow in it. So you could even, in the filter box, type in capital flow, and it'll come up. So take this endpoint, copy it, and paste it into our file here. And just like before, we're going to do datas equals request.get endpoint.json. And now what we're going to do is we're just going to print out the datas to see what kind of items are in here. And instantiate Webull by doing wb equals Webull, and capital flow or cap flow equals wb dot capital flow. And we're just going to run this. We're going to use Apple as the example for this one, and we're going to run this. So let's see what we get back here. Excuse me. So, okay, we see a big dictionary of data, a big dictionary of data. So again, the way that we get this down to the attributes, the raw attributes that we'll need to build the model for this, we simply do for item in datas. And since we know it's more than one item, being more than one dictionary, we can go ahead and zero off the datas to only bring back the first index. We're going to print the items or the item that's located in the data's zero index to get the raw attributes that we need. Let's take a look at what those are. Oh, we have a error. What is it? Okay, we have a key error for 0. So let's just go ahead and erase the 0 and just look at the items in datas. Cool. So these are our attributes right here. We have currency ID, latest, historical, clear, exist, clean time, and clean duration. The ones we're going to need out of this is going to be historical and latest. So we'll be able to get the latest capital flow data for today's date, and there's also a historical option as well. So to get the latest items, we simply do latest equals datas dot get latest, and then historical is datas dot get historical. And our data is not get historical. Now let's go ahead and print the items in latest. So for I or items in latest, print items. And let's see what we get back here in the terminal. What we're doing is we're breaking down the response object into smaller components to try to get to the raw attributes in each one. And in the latest, we have two more parent keys. We have date and item. Let's go ahead and define those. So date equals latest dot get date, and item is latest dot get item. Now we'll do the same thing. We'll break down the date for item. Let's do I in date, print I, and we'll be able to break it down further. And the date is just going to give us the latest date. So you can see, since we printed the items of just one date, it actually broke it into individual characters, which you can see here is 2023, 11/21, which is today. So we don't need to go any further for date. The date is just going to be the raw attribute for the current day. So we'll put a comment there. And for item, this is likely going to be the one that's holding all of our data that we want. So for I in item, print I. And this should be the raw attributes that we need for the main capital flow data. And there it is. So we have this big list of stuff here. I'm going to scroll up. And this is our data that we have to work with. So I'm going to go ahead and that's actually a long list. So what we're going to do here actually is to save us some time later. We're going to do this. Instead of just printing I, we're going to do F string, put the I in curly brackets. We're going to do self dot that, which is the I, and then we're going to do equals datas dot get, and then we'll put in parentheses in another curly bracket I, like this. And we'll put quotes around this. So now we can print this again, and it will already be formatted for us and save us a little bit of time for our model creation. Oh, it's going to give me a JSON error. Let's run this again. Computer's being a little laggy today. Let's try that again. There we go. So now what we can do is we can take this and we can copy it all because it is quite a long list of attributes. And then we're going to go to our models folder and we're going to make a new model. We're going to say capital flow.py. And from here, we're going to import pandas at the top as PD. And then we're going to say class capital flow. And then we're going to def init self datas. And then we're going to do this. Just paste that in and tab it all over. And what we have to work with here now is super large inflow, super large outflow, super large net flow, large inflow, outflow, net flow, new large inflow, outflow, net flow, new large inflow ratio, new large outflow ratio, medium inflow, outflow, and net flow, as well as the inflow, outflow ratio, small inflow, outflow, net flow, as well as the small ratio. Then we have the major inflow, outflow, and ratios involved, as well as net flow. And then lastly, we have retail inflow, outflow, and the ratios involved. So we can make a data dictionary for this, and it's going to be, pretty tedious, but this is what we can use ChatGPT for. So self.data dict, and since it's so extensive, and I want to be able to use GPT-3 for this, so no one has to pay anything to utilize it, we're going to just get this started. And what we're going to do is we're going to say, we're going to go up here to the top, and we're going to look at super large, in, out, and net. So we're going to do super in is self.super large inflow. Then we're going to do super out as self.super outflow. And then we're going to do super net as self.super net. And then we've gotten it started, right? So that should be enough to get GPT to do the rest. So now we're just going to copy this whole thing, head over to ChatGPT, GPT 3.5, and we're going to use it to construct the rest of our data dictionary. So if you have GPT-4, you could use that for likely a better response. We're going to go with GPT 3.5. I'm going to paste it to that in and be like, please finish the data dictionary as I have started. And let's see what it comes back with here. Certainly. Damn, GPT is going slow today. It normally would have already been done. Excuse me, man. The temperature dropped a lot today, and it's taking a toll on the health. A lot of people get sick when the temperature drops like this. So you can see it's correctly creating the data dictionary, albeit very freaking slowly. It rarely ever goes this slow, but it is what it is. There we go. Okay, so it's got our data dictionary for us. We're going to go ahead and just paste this in right here and just tab it over one time. And now what we're going to do is we're just going to create a self.asDataFrame equals pd.dataframe. We're going to pass in that self.dataDict. And then since it's a single index of data, we're going to have to do index equals, and in brackets, put 0. Now we go back to the main folder or function here. And what we're going to do is at the top of this file, now we can import our new model. So from models.capitalFlow, import capital flow. And at the function here, instead of returning or printing that statement, now what we can do is simply return capital flow, and then in the parentheses put in the item. So this will be for today's date. So we're going to do the historical one in another video. So I'm going to go ahead and erase this. We're going to keep the date. And what we can actually do is we can say item. Actually, we'll do that at the return function because we're gonna add the item to the data frame. We actually could do it here. Let's just do data frame equals capital flow item dot as data frame, and then we'll do data frame date equals date. That will add the date to the capital flow data frame, and then we will just return the data frame. And now what we can do is we can run this and print out capital flow, and we should get a nice data frame of today's capital flow data. Excuse me. And there we have it. So you see how the data frame's like vertical? I'm sorry, or horizontal. We want to make it vertical. So to do that, we're going to go back up to capital flow model and we're going to put dot transpose. That's going to flip it on its axis. And now when we print it, we should get a nice vertical uh, data to look at. And there you have it. So there's our super in, out, net, large, medium, small, major, and retail. Now the problem is that it's formatted in scientific notation, right? So to fix this, what we can do is you have a couple of options. You can make the helper function yourself. You can utilize GPT. You can look up help online. What do you want to do? I'm going to use GPT for this. And we're going to say, please create a helper function that will convert the large numbers in this data frame to appropriate sizes such as 4.4M or 1.2B or 1.8K, etc. Let's see what it comes back with. Please don't go slow. But it's going to. Oh, there we go. So we have the index here. Let's do another. Let's try this again. Make a dynamic one that will automatically convert any large numbers into the smaller abbreviated formats. Formates, I spelled that wrong. So now we can take this, we can make a new file called helpers.py, and we can go ahead and paste this in. Although I don't like this, so what I'm going to do actually is I'm going to just utilize a helper function that I already have made. And I'm going to go over to my repo real quick. Let's see here. We're going to go into the fudstop repo for a brief moment. We're going to go to fudstop. We're going to go to APIs, and we're going to go to helpers. And then inside this helpers, we should see that same function that we're looking for, which is going to be formatting the data frame values. And there we have it right there. So define format large number and then format large numbers in data frame. And we're going to go ahead and paste this. I think I actually may have a more advanced one that I made that's more dynamic. So let me just check that out real quick. in a new window, I'm going to open up another project folder real quick. And we're going to do open recent, FUD stop. This is the actual package that you just saw on the website. And then we're going to go to helpers again. And we're going to just copy and paste that same set of functions, which is format large numbers in data frame, which dynamically formats all the numbers for us. So we're going to copy these two over. Now I'm going to go back to our Webull tutorial. I'm going to paste these in to helpers, just like that. And then we just have to import at the top pandas. Import pandas as PD. So now when we go back here and we run this function, we just import it from helpers. So from helpers, import format large number. Actually, I think we only need format large numbers in data frame. And then now what we can do is we can simply do this. Data frame equals format large numbers in data frame, and then we return the same thing. Now let's try to print this, and we should get a more visually appealing output where we can make better use of the information that's being presented to us. So there you have it. Now we can easily see that the new large out is 168.6 million, 241 versus 348 or 381 for medium. And then for retail, we have 326 million in, 485 million out. So according to this, there's more outflow than inflow today. Looks like I need to adjust that function to account for negative numbers, but that's basically it for this one. Capital flow from Webull, formatted in a nice way. And you can do this for any ticker. Just simply replace Apple with GME or whatever you want. Paste this and look at the inflow outflow numbers for GME. And there you have it. So I hope this helps somebody, and we'll get into more of this as the videos proceed. So y'all have a good one.